In this lesson, we are going to pull it all together now and go through all 5 steps of a hypothesis test. So let's review all the steps, and then we're going to go through 3 examples, including the calculator method. Okay, so in step 1, you're going to state the null and alternative hypothesis. And the level of significance. So you'll say what the null is, which will be noted as h sub 0, and then you'll have some statement here. Then you'll have the alternative, which you'll have your HA, and then you'll make your statement here, and then of course you'll have your level of significance. So that's step 1. In step 2, you're going to decide the type of test, which would be right, left, or two-tailed. You are then going to choose the distribution. So, for example, normal, student T, or if we're looking at proportion, and we use the normal to approximate. Okay, and then also you're going to find your test statistic. Okay, in step 3, you're going to use your test statistic and you're going to use the rejection region approach. Then in step 4, you're going to use your test statistic to use the p-value approach. And then step 5, you're going to draw your conclusion. And you can write a sentence to interpret. So use this template as a way to write out your final sentence. So you're going to write at the blank level of significance and then in the blank you're going to put do or do not have enough evidence to conclude that, and then you're going to use the wording from the problem So you're going to use like the information from the problem to finish off the sentence based on what your decision is. Okay, so in this first example, we have an environmental protection agency that has been studying Miller Creek regarding ammonia nitrogen concentration. And for many years, the concentration level has been 2.3 milligrams per liter. However, a new golf course and new housing developments are raising concerns that the concentration may have changed because of the lawn fertilizer. Any change, either increase or decrease in ammonia nitrogen concentration, can affect the plant and animal life around the creek. So we're going to say let X be a random variable. that represents the ammonia nitrogen concentration in milligrams per liter. We're going to assume that X has a normal distribution and the population standard deviation is 0.30. And then we have the following information that was collected. And from that sample, we had a sample mean of 2.51. So the question is, has the concentration of ammonia nitrogen changed from 2.3 milligrams per liter? And we're going to use a 1% level of significance. So the first step is we need to determine what the null hypothesis and the alternative hypothesis is. So we're going to write down what those are. Now we're checking the means of the nitrogen level, so we're using mu's. Now in the past, and it says here, traditionally, let me highlight it, traditionally it has been 2.3 milligrams per liter. So I'm going to say that mu for the null hypothesis, mu is 2.3. We need to check to see if there's either an increase or a decrease, any change. So our alternative hypothesis is that mu is not 2.3. And our level of significance is 1%, so alpha is going to be 0.01. Now, part 2, we're going to determine the type of test. Because we're looking to see if there's been any change at all, not necessarily in any one direction, this is going to be two-tailed. We're going to find our test statistic. Since we're given the population standard deviation and they're telling us that this has a normal distribution, we're going to use the normal distribution for sampling, and our test statistic is going to be z equals our x bar minus our mu divided by our population standard deviation over the sample size, the square root of the sample size. So when we put that information in, we have that our sample mean was 2.51, our mu is 2.3, our population standard deviation is 0.3, and we're going to divide by the square root of 8 because that's how many items we have in our sample. All right, in fact, let's add that up here. Our sample size is 8. Okay, now when you put that all in your calculator, you're going to get an approximate value of 1.98. Okay, step 3, we're going to do the rejection region method. Now, because our alpha is 0.01, we are going to look for our rejection region so that we have 0.5% in each wing, which would give us 0.005. That would give us, when we use inverse norm to find those values, that would give us our z critical to be 2.576 and negative 2.576. So when I look at my test statistic of 1.98, that's going to fall somewhere out here. So here's 0 in the center. 1.98 is going to fall between 0 and 2.576. So it is not in the rejection region, which means we do not reject the null hypothesis. Now, let's do the same thing for the p-value approach. Our test statistic is 1.98. And so when I use symmetry, we're going to have negative 1.98 on the other side. So we're looking for the probability that it falls in either one of these regions. So I need to find the probability of this shaded red area and then multiply it by 2 based on symmetry. So I'm going to take 2 times the probability that z is greater than 1.98. Using the normal distribution on the calculator, we can find the probability that we're going to get a value higher than 1.98 we're going to find that that p-value is 0.0239. Then when we multiply it by 2, because we have to double it for each, because we have the two wings, we're going to get 0.0478. So this is our p-value. So that tells me that since the p-value is greater than my alpha level, we're going to say do not reject the null hypothesis. Okay, last step, we're going to make our conclusion. We're going to say at the 1% level of significance, there is not enough evidence to conclude. Now this is where we're going to take the information from the problem to finish writing the sentence. That the nitrogen concentration has changed. Okay, there's the first example. Now let me show you how you can check this on the calculator. Okay, so to check your answer on the calculator, we're going to hit the stat button, then we're going to arrow over to tests. Because we used a normal distribution here, we're going to choose z-test. I'm going to put in my statistics. Again, you have that option if you have the data, which we do in this case. You can try it both ways. If you have the data, you can put it in one of your lists and enter it directly from there. But since the problem additionally gave us the statistics, we can just put it in as it is. So I'm going to put in this first step that our mu is 2.3. Then we're going to put in our population standard deviation, which was 0.3. And then we're going to put in our sample mean, which we got was 2.51. And we're going to put in our sample size, which is 8. And then when we get down to this row, we're going to choose whether it's two-tailed, whether we're looking to see if it's not equal to, whether it's less than, that would be if it's a left-hand test or a left-tailed test, and then if it's greater than, if it's a right-tailed test. So choose the type of test you're using. Then I'm going to click on calculate. And then it gives you the information here. This is what our alternative hypothesis is. Then it goes down and it states our test statistic. And when we did our test statistic, we rounded it to two places. We rounded it as 1.98. This gives you all the values of your test statistic, so you can check that. Then it also gives you your p-value. So from the value of your test statistic and your p-value, you can make a conclusion whether you want to reject or not reject the null hypothesis. Looking at the second example, it says archaeologists become excited when they find an anomaly in discovered artifacts. The anomaly may or may not indicate a new trading region or a new method of craftsmanship. Suppose that the length of a projectile points, meaning arrowheads, at a certain archaeological site has a mean length of 2.6 centimeters. A random sample of 61 recently discovered projectile points in an adjacent cliff dwelling gave a sample mean to be 2.92 centimeters, and the sample standard deviation was 0.85. Where x is a random variable that represents the length of the projectile points at the adjacent cliff dwelling site, does the data indicate that the mean length of projectile points in adjacent cliff dwelling is longer than 2.6 centimeters? And we're going to use a 1% level of significance. So step 1, we want to state our hypothesis and our level of significance. So we're looking at means here again. So my null hypothesis is going to be what it has been in the past. So that's mu is equal to 2.6 centimeters. The question is asking if the arrowheads found in this cliff dwelling is overall longer than 2.6 centimeters. So we're going to set up an alternative hypothesis that the mu is greater than 2.6, and we have a level of significance of 1%, which is 0.01 as a decimal. So there's our step 1. Step 2, we're looking to decide on what distribution we're going to use and find our test statistic. So, because we are not given the population standard deviation, and because our sample size is greater than 30, because of these two reasons, we're going to use the student t-distribution, which means our test statistic is going to be t equals x bar minus the mu over sample standard deviation over the sample size, the square root of the sample size. All right, now when we put all that information in here, looking back, it says the mean of the sample is 2.92. Our mu is 2.6. The sample standard deviation was 0.85, and we have a sample size, it says up here is 61, so we're going to take the square root of 61. Now, when we put all of that in on the calculator, you should get 2.940 approximately. Now, because we're looking to see if this is greater than 2.6, this is going to be a right-tailed test. In step 3, we're going to do the rejection region method. Because this is right-tailed, and this is a 1% alpha, we want to look for that cutoff point so that we have 1% in this tail. So I got to find t critical that gives me that value. So I'm going to do inverse t on the calculator to find that value. I'm going to find that that t critical is 2.39. So now when I look at my test statistic here, 2.940 falls in that rejection region. So we would say reject the null hypothesis using the rejection region. Now let's do the same thing checking the p-value method. So we need to find the probability that t is going to be greater than 2.940. Now use your TCDF for that on your calculator. When you put all that information on your calculator, you should get that the p-value came out to be 0.002327. That's approximately. Since our p-value is smaller than our alpha, we have 0.0023 is smaller than 0.01. We're going to say reject the null hypothesis. Okay, so our step 5 is to write out our conclusion. So we're going to say at the 0.01 level of significance, there is evidence to reject the null hypothesis, and that the mean length of the arrowheads is longer than 2.6 centimeters. Calculator, we're going to hit the Stat button, then over to Tests, and then we're going to choose Z-Test. And then we're going to choose T-Test because we're using the T-distribution. We're going to put in all of our information. Our mean, our mu was 2.6. Our sample mean was 2.92. Our sample standard deviation was 0.85. Our sample size was 61. And because we're doing a right-tailed test, we want to make sure that we're over here where it shows the greater than symbol. And then I'm going to arrow down and hit the calculate option and hit enter. And it's going to give us our t-critical and our p-value. So here's our t-critical that we calculated in the third step, or in the second step actually. And then here's our p-value that we calculated in the fourth step, which is 0.00232. And so we know that we did it by hand correctly. So that's how you check your work on your calculator using the t-test option. Okay, in this last example, it says a botanist has produced a new variety of hybrid wheat that is better able to withstand drought from other varieties. The botanist knows that for parent plants, the proportion of seeds germinating is at 80%. The proportion of seeds germinating for the hybrid variety is unknown, but the botanist claims that it is 80%. To test this claim, 400 seeds from the hybrid plant are tested, and it is found that 312 germinate. Use a 5% level of significance to test the claim that the proportion germinating for the hybrid is 80%. Okay, so we're talking about proportions here. So in step 1, we're going to set up our alternative and our null hypothesis. Since we're dealing with proportions here, we're going to use p, not mu. And what we're doing is we're testing if the proportion of seeds that germinate is 80% or not 80%. So my proportion is going to be 80% for my null hypothesis, and then for my alternative hypothesis, we're going to have does not equal 0.80. And our level of significance is 0.05. In step 2, we're going to determine the distribution that we're going to use and our test statistic. So because we're dealing with proportions, we want to check to see if we can approximate it with the normal distribution. So we need to check if n times p is greater than 5 and if n times q is greater than 5. So for n times p, we have a sample size of 400, and if we multiply that by 0.8, we get 320, which is certainly greater than 5. If we check our inequality with the q, we have 400 times 0.2. That's going to give me 80, which is greater than 5. So both of these work. So that tells me, in this case, we can use the normal distribution to estimate p prime. So to find our test statistic, we use p prime minus p over the square root of p times q over n. So we're going to put in 0.78 minus 0.8 over the square root of 0.8 times 0.2 all over the sample size, which is 400. Now I got that 0.78 because when they used the sample, they found that 312 out of 400 seeds germinated. So if I take 312 over 400, that gives me 0.78. So that's where I got my P prime from. All right, now, when I put that all in on the calculator, I get -1. So there's our test statistic, and I'll label it with a little T to remind us that that's our test statistic. So now in step 3, we're going to use the rejection region method. Since we're approximating using the normal distribution, and in this case, we're doing a two-tailed test. Actually, I think I forgot to write that up there. Let's write this down. Two-tailed test. And it's a two-tailed test because we're looking to see that it's not equal to 0.80. So in our level of significance is 0.05. So I want to break up my rejection region, because it's two-tailed, into 2 halves. So I'm looking for my Z critical, my cutoff point, so that this is 0.025 and this is 0.025 for my area. Now, when you do that on the calculator, you're going to find that this cutoff point is 1.96, and this will be -1.96. So now, if we look at our test statistic, we found our test statistic to be -1. So 0 is in the center. 0 is in the center. And when I draw my -1 on the graph, it's going to be somewhere between 0 and -1.96. So that means do not reject the null hypothesis. Now let's check this with the p-value method. When I draw my -1 on the graph, and then I also want to do, using symmetry, +1, I want to find this area of the rejection region on either side. I want to find what this probability is and then multiply it by 2 because the areas are symmetric and we've got 2 of them. So I'm going to find 2 times the probability that we get a Z that's less than -1. If you want, another way to write this is you can say, you can find the probability that you're going to get a Z less than -1 plus the probability that you get a Z that's greater than 1. If you find each of these separately and add them up, it's the same thing as doing 2 times one of them since it's symmetric and it has the same area. Either way, it's fine. I like using this first method here because it's less work. So I'm just going to take 2 times the probability. So when I use normal CDF on my calculator and I find that probability, doesn't matter which wing, just you're going to find it that it's the same area no matter which way you do it. You're going to find that one wing has an area of 0.1587. And then when you multiply that by 2 for both wings, you're going to get 0.3174 for your probability. Now, because your p-value is greater than your alpha, right? Our alpha was 0.05 and our p-value is 0.3. So our p-value is greater than our alpha. So we would say do not reject the null hypothesis. And step 5 is our conclusion. So we would say at the 0.05 level of significance, there is not enough evidence to conclude that the germination rate is not 80%, or you can say it as 0.80. All right, now let's check our work on the calculator. Proportions here, we're going to go to the stat button, I'm going to arrow over to tests, and we're going to choose one proportion z-test. And then I'm going to hit enter, and then I'm going to put in all of our information. We said that our P was 0.8. We had 312 successes out of 400. This is a two-tailed test, so I want to make sure I hit the do not equal symbol. And then I'm going to go down and I'm going to hit calculate. And it's going to give me my test statistic, which is z is equal to -1, which is what we got. It's going to give us our p-value, which we got when we did it by hand, we got 0.3174. It's a little bit off with the rounding. And then it gives us our sample proportion, which we already figured was 0.78 in our sample size. So we can check our p-value and our test statistic against what the calculator gave us so that we make sure that we use the right information to make our decision.